Cognitive Processing by Marisha Tones and McKenna Williams. So information processing theories and models. Information processing theory is the cognitive theory of learning that describes the processing, storage, and retrieval of knowledge from the mind. For this model, you take in information and it goes into your working memory, which is also known as your short-term memory. Depending on how meaningful and how much the information is used, it will stay in your short-term memory or be transferred to your long-term memory. Information in your working or short-term memory is often forgotten. Information in your long-term memory is remembered and able to be retrieved when needed. As teachers, we see how information in short-term memory is forgotten in a variety of ways. And one example of this is a spelling test. Oftentimes, students can easily get every word correct and get a 100, but then later not know how to spell a word from the test in their writing. An example of long-term memory would be remembering your graduation day, and this is likely a day that you gave great attention to, which is why it's likely to be in your long-term memory.
GOES model, also known as the bottom-up approach. In this model, there are different stages that work together through the reading process. The iconic image, this is what you see. You remember this while the scanner takes over. The book uses the example of a letter. The scanner takes over to identify specific patterns that can be used to identify the letter. Character register stores the iconic image as a letter. Decoder, the decoder takes over once the iconic image has been identified as a letter. During this process, a codebook helps to attach the right phonemes to each letter, which ultimately is recorded into a phonemic tape. Librarian, this is where the letter and sounds are put together to make words, and the lexicon, which stores the meaning of words. Primary memory, which is where sentences are built, and which is meanings of sentences are created and then sent to the TPWSGWTAU, the place where the sentences are stored once they are understood.
Next, we have the automatic information processing model, and there are 5 main pieces to this model, which are visual memory, phonological memory, episodic memory, semantic memory, and attention. So visual memory is first. This is where the features of letters are remembered and will start to become automatic. Phonological memory is where sounds come in and are attached to visual image of the letter. Episodic memory is the recording of context information. Semantic memory is where other knowledge is stored. In attention, there are 2 types, external and internal attention. External attention is information gathered through observable attention, and internal information is the attention within an individual's mind and can often be unrelated to the topic at hand.
Next is the interactive and interactive compensatory models. The interactive model uses numerous sources during the reading process. 4 processes work together, and they are the syntactic, semantic, orthographic, and lexical. Interactive compensatory model uses the same concepts of the interactive model, but if one of the 4 processors above is not working to its ability, then a different processor needs to record or compensate for the processor that's not working effectively.
Phonological core variable difference model. In regard to dyslexia, Stanvich argued that the primary difference between individuals with and without dyslexia was determined by deficits in the phonological realm of cognitive functioning. Cognitive ability refers to one's ability to hear and manipulate sounds within words. Children with phonemic awareness deficits are slower to break the sound symbol code of reading. Stanvich placed heavy emphasis early on in the area of phonological deficits in order to understand and treat at-risk readers. The phonological core difference model is identified as a cognitive processing model because its central feature is a deficit in the phonological processor.
Next is the parallel distributed processing model. In this model, there are two central features. One is all cognitive information is stored as a series of connections between units, and two, these connections between units become stronger and faster with repeated pairings. This model is a connectionist model of reading, meaning connections between different units are continuous and are always subject to change over time based on experiences. Successful reading is dependent on a reader's ability in 4 categories that include automatic letter recognition, accurate phonemic processing, strong vocabulary knowledge, and one's ability to construct meaningful messages during their reading. The reading process begins in the orthographic processor where print recognition happens. The second processor, or meaning processor, attaches the meaning of vocabulary to words identified in the orthographic processor. The third processor is the phonological processor, which is where the sounds associated with words are processed. The last processor is the context processor, which is where readers construct and monitor the meanings of phrases, sentences, paragraphs, etc.
The dual root cascaded model. This module is similar to the previous one in that they are both computer-based models that encode text and output sound. The main difference between this model and the previous one is that this model reads all words and non-words in a single path that exists for turning print into sound. This model has two routes for processing text input. One, handling words that are already known to the reader, lexical, and two, handling words, unknown words and known non-words, non-lexical. The lexical route can be thought of as a whole world or sight word approach to reading in which words are automatically recognized rather than broken down according to sound symbol relationships. The non-lexical route, based on letter to sound rule procedure. This route is used only for word/letter strings that are unknown or unfamiliar to the reader.
The double deficit hypothesis. This hypothesis was proposed in order to try and explain the cause of reading disabilities. Wolf and Bowers argued that children with reading disabilities fall into one of these 3 categories. 1. Children for whom phonological deficits are the core of their reading disability. 2. Children for whom naming speed deficits are the core of their reading disability. And 3. Children for whom both phonological deficits and naming speed deficits are problematic. Children that fall into the 3rd category are ones that have the most severe reading impairment. This is known as the double deficit.
The neuroscience and education, how are they related? One of the fundamental pillars supporting the link between education and neuroscience is the ability of the brain to learn. Neuroscience is developing and increasing our understanding of early brain development and how these brain changes might relate to learning processes. Cognitive neuroscience, the study of higher patterns of brain functioning through brain imaging technology.
The end. Thank you.
Thanks for watching.